Hello everyone. I'd like to continue the discussion regarding the ionic compounds as we discussed in the previous section, the formation of ions, and then we will looking at a need to communicate. So here is the one for nomenclature, means the names and the formulas for ionic compounds. Here's again is the ever important table. We call it the periodic table of elements. And you will see the columns, all the group of families of elements, and you can have 1 through 18, and you will have periods, the rows 1 through 7, and those are different families. This is alkaline. There's alkaline earth metal. This is alkaline metals. This is the alkaline earth metals, noble gases, halogens, oxygen groups, nitrogen group, and the list goes on now. And in the middle is the transition metal, and they have 2 series: lanthanoids and actinoids. So what actually you learned in the previous units, and all this has been driven by the octet rule. All the elements in the noble gas group have the most stable electron configuration. So all the other elements on the periodic table would love to achieve the electron configuration that is same to the noble gases, and that is driving a lot of the chemistry. And in this particular case, we're going to look at the formation of ions. As you can see, we use this. I used this example before when a sodium atom is kind of in the vicinity of a chlorine atom. As you can see, the electron configuration for chlorine have an outermost shell. The valence shell has 7 valence electrons. How is it going to get 8? Easiest way to grab the electron, and to gain electron becomes chloride ion. In this case, chloride ion go from chlorine to chloride ion. As you can see, the size increases due to effect number 3. Same token, you're looking at the valence shell electron configuration for sodium. It's more economically in energy just simply to lose that valence electrons. And so this is when you lose the valence electrons of the sodium plus ion, it's smaller than sodium atom. As we can see from here, the sodium atom used to be larger than the chlorine atom, but however, after the transfer of this particular valence electrons, the order reversed. The sodium ions are significantly smaller than the chloride ions. But when they formed ions, and let's do a little mental exercise. If you have a big chunk of, in this case, salt. So those are the table salt. Okay, if you have the big crystal, so those have the big crystals, and they do not move against each other, and as you can observe. But when you grind them up, it's small crystals. You can crush them, and you become a small powdery substance. But still, if you spread them out, you do not see the really fine crystals of table salt that is moving against each other. So what actually does that mean? If they do not move against each other, then they have to be charge neutral. Otherwise either they will have the same sign of charges, then they're going to repel. If they have the opposite sign of charges, then they're going to attract. So the mere fact we're looking at here, so when you can see the logical extension is we start breaking them down, physically, and the fact they do not move against each other. So each of the small units is charge neutral. But now you can extend this logic argument. Say, if really I have to chop this, the tables are crystal down and chop to the point, you cannot do it anymore. You will have what we call it formula unit. So those are called formula units. This is the simplest units that's representing the ionic compound. And recall the information we discussed in the previous vodcast regarding this. So then the very important conclusion, all of them are charge neutral. Meaning the positive charge is brought in by the cation has to be cancelled out by the negative charge, by the negative charge brought on by the anions. So all of them are charge neutral. So then whatever the sum of the charge for pluses has to equal to the sum of the charge for minuses. Very, very important, very important relationship. Okay, so then let's take a look at if we have a sodium meets with chlorine gas. This is a solid, this is a gas. What will happen is the sodium is still going to be a solid, but now chlorine is becoming separated, and those are becoming two chlorine atoms in the gas phase. Okay, so in this case now we're looking at sodium and chlorine. So sodium has as we indicated before, 1 valence electrons. Chlorine has 7. Now we have this transfer of valence electrons, and we're going to get sodium plus and chloride minus. So we have the chloride minus. This is the simplest form of the formula unit. So the formula unit for the table salt will be NaCl. NaCl. First thing you notice, no charge has ever indicated on the formula unit. No charge shown on the formula unit. But you know those are ions, those are sodium plus ion, and this is actually sodium plus ion. This is actually chloride minus ion. So in this case, if we have 1-to-1 ratio, the sodium plus charge will be cancelled out by the chloride, and by the negative charge from the chloride. Okay. And the naming convention is for the positively charged ion will be called sodium, will be the same name as the element, and the chloride, and it's going to be changed into chloride. And also, this is how we actually coming with this formula unit is going through the process is we know the charge on sodium is +1 and charge on the chloride is -1, dictated by the octet rule. So this one will be the +1, this one will be the -1. So you will say, oh, they are perfectly matched, and each one I only need one, so I have positive 1 and a negative 1. So the sum of these two terms will becoming 0. So we can actually write it sodium chloride. And let's take a look at some couple of other examples. And this one is actually what we're going to talk about, is if we mix calcium, solid calcium with nitrogen gas, actually react with nitrogen gas, it will start reacting and it will form what? And we know the calcium, if you look on the periodic table, that's group 2, it's tend to lose 2 valence electrons to give you the calcium 2 plus. Nitrogen, they give you 2 nitrogen atoms. Each nitrogen atom will going to lose again 3 valence electrons because he has 5 valence electrons. So you're becoming a nitride. So the compound here will be the calcium nitride, and to put it together into a formula unit, and we'll go through the process. It's calcium 2 plus and nitride 3 minus. Charge on each ion, calcium is plus 2, nitride is minus 3. So how do you get the plus 2 and minus 3? How come they can actually cancel each other out? This is something is called a least common multiple problem. So there will be this one multiplied by 3. The least common multiple will be 6, and this one I would need to multiply by 2. So this is plus 6, it is minus 6. The sum for this is 0. And now I start to circle them. What the meaning is the formula unit for calcium hydride is Ca3N2. So those 2 are what we called subscripts. Okay, that is indicating you have 3 calciums and calcium ions and 2 nitride ions put it together can give you the correct representation for calcium nitride. In order to complete the ions, and let's take a look at this list names and the charges of some ions. And the first part is positive ions, and you have the familiar ones: cesium plus 1, copper 1, and Cuprous Cu plus 1, hydrogen plus 1, potassium plus 1, rubidium plus 1, silver plus 1, sodium plus 1. And now you start seeing some see, like this one, ammonium and H4 plus. You start noticing it's not a single atom anymore. You have 1 nitrogen. For hydrogen, when these 5 atoms get together, you form a plus 1 charged ion. This is what we call it polyatomic ion. There's another polyatomic ion that's positively charged. It will be the mercury 1. Because for 2 of mercuries get together, the ions actually carries a plus 2 charge. So each one of them will carry plus 1. The other observation is, now we actually have a copper ion, and it's plus 1 charge. Also we have the copper ion that is actually have plus 2 charge, so you have multiple charges on the copper ion. Since the name for the positive charged ion, the cation, is the same as the element, both of the ions are called copper. How could you tell them apart? So you actually use you use the ones in the parenthesis to tell the charge on those metal ions. So in this case, it's a metal, it's copper 1, and that will be copper 2. And you can see a lot of those transition metals is right in the middle block. The transition metals has multiple charges. Also, the one is post transition metals, and bismuth, you have 3, and you have the other charges. Okay, so then you can have where's my okay, you can have manganese 7. So I want to see the highlighter. You can have the manganese, it could be 7, and manganese, it could be 2. So you have to tell. Tin, you can have 4. Tin, you can have 2. Okay. As you can notice, for transition metal, zinc only has 1 plus 2. Silver has only 1 plus 1. Iron, you probably have 2. Iron, you can have 3. So this is the list for positive ions. Remember, there are 2 polyatomic ions. That's positive. One's mercury 1. The other one will be ammonium. And also you notice here, there's this, the ammonium is the only one, and the hydrogen is the other one. That is positively charged ion. That has no metal in it. For the selective negative ions, and you will see the familiar one: the bromide, the chloride, the chloride, the fluoride, and the iodide. So those are the typical ones. This is the monoatomic ions for halogen gas small elements. However, quickly then you start noticing some ions, negatively charged ions, that will have negative charged ions, that will have more than one kind of atoms. So this is called polyatomic ions. Like this, like cyanide, you will have carbon and nitrogen, and it carries -1 charge. And the list goes on and on. And you will need to remember some of those polyatomic ions. But one of the things it's unique with the polyatomic ions is I always advise put a parenthesis around it. If you see a polyatomic ion, you put a parenthesis around it, because that means this is a single unit. For instance, if I want to write the carbonate, 0.3 2 minus, actually carbon is linked with oxygen. Okay, carbon is linked with oxygen. Actually, this whole unit carries a -2 charge. Very, very important. You remember that. Very, very important. You remember that. So let's talk about what we talk. The special ones, transition metals. And some of the post-transition metals. They have multiple charges, sometimes referred to as valences. So then we have to use the cation and the Roman numeral inside the premise, inside the parenthesis, to indicate the charge. For instance, if it's 3, that will be equivalent to X3 plus. The other ones we noticed are polyatomic ion, those ions are composed of more than one atoms in its entity, and as a whole it carries certain given charge. So then let's take a look at some examples. In this case, now we're having the ammonium carbonate on the list. You quickly will recognize ammonium BuNH4 plus, carbonate will be CO3 2 minus. Let's go through the process. This one is +1, that is -2. How you get them to 0? LCM, least common multiple. So in this case, I need to multiply this by 2. I will multiply this by 1. So this negative both parties to cancel each other out. I need a 2 of this, 1 of that. Remember, polyatomic ion immediately bracket. So there will be NH4 2 CO3, and this one will be 1. So by convention, we drop the 1, and also we drop the 2 brackets surrounding carbonate. So the final formula unit for ammonium carbonate will be NH4 CO3. Okay, so now you'll have the second example is iron 3 carbonate. So then iron 3 will be indicating 3 plus, carbonate will be CO3 2 minus, +3 -2, and you're trying to get them to -6 +6. So this is 2, this is 3. So the formula unit for iron 3 carbonate will be Fe2 CO3 3. Okay, and just make sure this one is a circle too. The last one is aluminum peroxide. Aluminum is, as you can see, is located in the group 13 elements. So the aluminum will be 3 plus. Peroxide, check on the list, and eventually have to memorize, is O2 2 minus. So as a whole, O2 is 2 minus 2, and this one is +3. How you get to the least common multiple, and as you can see, -6 +6, and they even out when you add these two together. So those are the numbers I start to circle. And they will be Al2 CO3 3. That will be the formula for this particular ionic compound. And the little bit more difficult part will be the going in the reverse. So now let's take a look at this particular one and trying to come up with the correct answers. And as you can see through here, check on the list, and this one will be nickel. We don't know the charge yet. Sulfate. So then this one will have -2 charge on its polyatomic ion, and nickel we don't know yet. So each one carries -2. You'll have 3, so it's -6. So on the positive side, it has to have +6 because this has to be cancelled. Now you know you have 2, and what actually the charge is indicated here. So then it has to be the question mark has to be 3 plus. So this is 3 plus. So you put these two together. So that one will be called nickel 3 sulfide. Okay, so this one is going to be called nickel 3 sulfide. And right now let's take a look at this formula unit. You have a calcium and you have the phosphide. Remember, phosphor has 15 electrons, and all the way you can have you can have phosphorus, you can have phosphide. This is phosphide dictated by the octet rule. So if you see calcium is group 2, always going to be group 2. It will be 2 plus. Phosphorus will be 3 minus 2 plus minus 3, same thing, times 2 minus 6 plus 6. So they cancel each other out, but that's how you'll need those. So this one will be called calcium phosphide. That will be the name for this compound. Now you start to notice, to identify this is a polyatomic ion, this is a PO3, 3 minus, this is phosphide. Okay, and now you have Cu, I don't know the charge, minus 3, I have 2, minus 6, on this side I have the plus 6, and now I don't know the charge, but I know I have 3 of them. So this charge will equal to plus 2. So hence the name for this CO3 PO3 parenthesis 2 will be copper 2 phosphide. Okay. Just want to be sure I covered all the aspects of how we name the ionic compounds and how actually we can take the nomenclature of the ionic compound, actually a backtrack about its composition. And with that, I wrap up this podcast. Please check your corresponding homework worksheets for exercises. Thank you very much.